everybody, and welcome to another lesson here, 6.6 Part 2. Today, how do you factor and solve polynomials using division? So we learned polynomial synthetic division last lesson. This time we're going to use that to solve the polynomials. Okay, here are the general steps. Write a zero out as a factor, divide using synthetic or regular division, and factor and solve the result. The new bit today is that we have a new theorem that basically can take any factor or any zero and make it a factor. So for these problems, find all the zeros of the function. One of them is given to you, so that's what this 5 is. That's a freebie zero. Freebie, yay. What this can be written as then is the factor x minus 5. So factors are the opposite of zeros, in a sense. So if you have a 0 of -3, its factor would be x plus 3. So that's how those are related. Okay, so that would be a factor, and we're already given the 0. Now, another fun fact is that the 4 represents how many solutions there are. That is from the fundamental theorem. So the fundamental theorem of algebra, the fun theorem, tells us that there are 4 solutions. Okay, so our goal is to find them. The first one is already given to us for free, and that's the x equals 5. Now to find the other two, we can start by using synthetic division. Okay, so we're going to start with the 5. We actually write the regular 5 because remember, if this is our factor, then we can just write a regular 5 here. Writing the coefficients in, 1, -1, -18, -2, -40 begins our next step. As we continue synthetic division, we can bring the 1 down. 1 times 5 is 5, and that's going to give us 4. 4 times 5 is going to be 20, gives us -2. -2 times 5 is -10, and combined gives us -12, and gives us +2, whoops, which gives us +10, which gives us 8, which gives us 40, which gives us 0. So notice I caught myself there. Now, why did I do that? Because I knew I should get 0 as a remainder. If this is a factor, you should always get 0. So if you don't get 0 and you know it's a factor, you know you might have made a little mistake there. So I caught it there. Maybe you did too, but that is what it comes out to be. Now remember, this represents x to the third plus 4x squared plus 2x plus 8. When you get to this point, you are going to have to use your other factoring skills to keep going. So this is why we did some factoring with grouping. Remember, you can bring out x squared from these two pieces. That gives us x plus 4. We can bring out a 2 from the other two, and that gives us x plus 4. Therefore, we have the factors x squared plus 2 and x plus 4. Now, solving each of those is our last step. So we're almost there. These problems take a little more time, but once you do them, they're a breeze. X plus 4 equals 0, you would subtract the 4. So x is going to equal -4. On the other side, we have to remember a few of our other things. When we subtract 2, so x squared equals -2. When we square root, anytime you square root, you do not forget plus or minus. And if there's a negative inside of a square root, it comes out as an I. I roots of 2 equals x. So our goal was to find 4 solutions, and there they are. X equals -4, x equals plus or minus I roots of 2. It can be a little hard to see, but the I roots of 2 is two answers. There's a positive version and there's a negative version. So we did find all four. If you want to write them back down, that can be helpful. Now that we have all that, let's just try this out one more time on the next example. Now I know that this can be a long and tedious process, but really, once you get around to it, it's not so bad. So we know that there are four solutions due to our fundamental theorem of algebra. And our first one's given to us, x equals 3. That's our freebie. So remember, it's a factor, which is x minus 3. And from there, we can start our synthetic division. So 3, 1, negative 4, 4, negative 4 again, and 3. Start our long or synthetic division process. Just remember the coefficients. And we bring the 1 down, and we multiply to 3. It gives us negative 1, which gives us 1. This makes another negative 1, and negative 1 times 3 is negative 3, which gives us 0. Time for a little happy dance that we got that. So left now is to factor x to the third minus x squared plus x minus 1. Not always, but most of the time it's a good idea to try out factoring by grouping. The first two, we can bring out an x squared. And the second two, harder to see, but we can bring out a 1. And that's just going to leave x minus 1. So this is why we did some of our factoring work with grouping. So we split both of those up. We set them equal to 0 next. Split them up and solve. The right-hand side isn't too bad. X would just be 1. The left-hand side, you need to remember once again, negatives. So it's going to be x squared equals negative 1. Which then, when you square root, don't forget the plus or minus, you get x equals plus or minus the root of negative 1, which is simply plus or minus I. So we found, once again, all four of our solutions, positive I and a negative I. Great job, everybody. Once again, a little tedious, but we can get through it. Let's try out the next one and become pros at our solving of higher order polynomials. So if you want to pause and try it on your own, you could do that. I'm going to dive on in. We know there's four solutions. We know one of them is x equals 2. So what goes out front? A regular 2. Set up our synthetic division. Bring down the 1, multiply to 2, which gives us 2. Add together gives us negative 3. Add together gives us 1. Add together gives us 2. Add to gives us negative 3. And we hope for a happy dance again with 0. Awesome. So we can set that up and prepare to factor by grouping. That's what's looking like here. X squared comes out of the first group. Another plus 1 comes out of the second. And then you can make the two factors and solve those independently. Once again, be careful with the negative 1. Square rooting it. Remember the negatives in the square root. I know it's been a while, perhaps, since you've done negatives and square roots. but really they're not super bad. Just remember to bring an I out if it's a negative square root. Okay, 1 solution, 2 solutions, 3, and 4. So awesome. If you are feeling good, once again, try out number 4 here. And as I get going, you can check your work at the end. Pause it here, try it, and return back when you need some help. Happy dance time with a 0. Awesome. And we're ready to factor by grouping. Bring out an x squared. Bring out a 4. Write our 2 pairs, x squared plus 4, x minus 4 equals 0. And split it on up from here. We would have x equals 4. And the left side, once again, be careful. More funky imaginary stuff going on. When we square root plus or minus negative 4, square root of negative 4 is I roots of 4, and the square root of 4 is plus or minus 2, and the I can go after it. So great job. Hope you did all right, guys. A long, tedious process, but I know that you can do it. Remember, we're aiming to find 4 solutions. If anything, you might have to find 5, but just a taste of what is to come. So great job, guys. Practice those, please. Check your answers, and enjoy the rest of your day.